Hello there and welcome to the show. Today is September 30th, 2025, a Tuesday. And you know what that means. It's time to pull a real gem from the archives. A trending paper that's got everyone talking. Alright, let's see what we've got here. The title is Very Stimulating Dense Image Caption Capabilities via Reinforcement Learning. The curl is Labs, Bayfab 09.22,647 line. It's long, so let's break this down. Image caption and writing. That's when an AI looks at a picture and writes a description of it. It sounds simple, but it's super important for training these big vision language models, the ones that connect what they see with what they can say. The big problem in this paper is tackling is how these models are usually trained. They use something called Supervised Fine-Tuning or SFT. Basically, you show the AI a picture and give it one single, film-written caption, the ground truth. The AI's job is to learn how to perfectly copy that caption. Oh, think about it. That's not really how we describe things. A single image can have a ton of different, equally valid descriptions. This method makes the AI really good at memorizing one specific answer. But it doesn't make it creative or flexible. It's like teaching a kid to pass a test by just memorizing the answer key, instead of actually understanding the subject. So, the researchers here thought, let's try something different. Let's use reinforcement learning. Now, the model learns by getting rewards for good behavior. But that leads to another tricky question. What exactly is a good caption? That's so subjective. Previous attempts tried using another AI as a judge to give rewards, but that just led to chaos. The captioning AI would figure out the judge's weird biases and just exploit them. Like if the judge AI liked long sentences, the captioning AI would just start writing super long, rambling descriptions that were mostly nonsense just to get a good score. They call this reward hacking. This is where CapRL, the method in this paper, gets really clever. It completely redefines what a good caption, according to CapRL, is a caption that is useful. How do they measure utility? Well, they set up a two-stage system. In the first stage, the AI we're training, let's call it the policy model, looks at an image and writes a detailed caption. And in the second stage, they take that caption and give it to a totally separate AI, a language model that cannot see the image at all. Along with the caption, they give this second AI a multiple. They'll all a question about the image. If the caption is good enough, detailed and accurate enough, the blind AI should be able to answer the question correctly just by reading the text. The reward is simple and objective. Did the blind AI get the answer right? If yes, you get a reward of 1. If no, you get 0. There's no subjectivity, no bias to hack. It's a clear, verifiable signal. What do you call an AI that only reads descriptions? A science-seer. Right, anyway, this simple idea is a game changer. It forces the captioning AI to generate descriptions that are not just pretty, but are packed with accurate, dense information. The results are pretty stunning. The 3 billion parameter model trained with CapRL was able to generate captions that were as informative and useful as those from a massive 72 billion parameter model. That's a huge leap in efficiency. So, let's think about some real-world applications for this. First, information extraction and text summarization. Imagine you have a scientific report with hundreds of complex charts and graphs. Normally, a person would have to manually analyze each one. With CapRL, the AI could generate incredibly detailed text descriptions of every chart, capturing all the key data points, trends, and labels. Then, another AI could read these text descriptions to create a summary of the entire report. It extracts specific data without ever needing to link to see the charts. This would save countless hours from researchers and analysts. Second, this is huge fun into dialogue systems, especially for creating accessibility tools for the visually impaired. A user could ask their phone, describe the painting in front of me, and instead of getting a simple woman smiling, it could get a rich, detailed description. Something like the portrait of a woman in her 30s with curly brown hair, wearing a blue velvet dress, sitting in a garden with sunflowers in the background, because the model is trained to be useful for answering questions. It naturally learns to include the very details people would ask about. And third, let's consider machine translation. Now, this isn't just about translating from French to English. Think of it as translating from the language of pixels to the language of words. A better, more detailed caption was a more faithful translation. Bernie Pramel sells its products globally. A Marco model could look at a product photo and generate a dense description, covering material, color, design details, even context of use. This rich text can then be accurately translated into dozens of languages, ensuring customers everywhere get a full understanding of the product. Far beyond what a simple, manually written type could provide. When you compare an output to other technologies, its advantages are really clear. Traditional supervised fine-tuning, as we said, is like revolutionizing. Skittle and not scalable. Other reinforcement learning methods that use an AI judge are flawed, because the judge itself is biased and can be easily tricked. The model might learn to just write, "My description is well organized and well structured," and because the judge AI has been trained to reward phrases like that. The Pro avoids all of this by creating a reward system that is objective and verifiable. It's not about pleasing a subjective judge. It's about successfully transferring visual information into text. It's a paradigm shift from making captions that sound good to making captions that do good. And that is a really fascinating step forward.